I'm Derek Ellerman with IAI, or you may know us as Intelligent Actuator. I'm here today to introduce you to our air cylinder replacement, the robo-cylinder. There's a big trend by some of the world's largest manufacturers to replace air cylinders with our electromechanical solution, the robo-cylinder. What is a robo-cylinder? A robo-cylinder is a direct air cylinder replacement with a servo-controlled motor directly coupled to a ball screw, and most operate off of a 24-volt power supply. There are many advantages to using a robo-cylinder over pneumatics. The first of which is flexibility. Since the robo-cylinder is servo-controlled, it can perform many functions that air cylinders simply can't. For example, we can control acceleration, deceleration, and velocity over infinite positions. Most basic air cylinder applications extend and retract only to 2 positions and at the same velocity and acceleration. The robo-cylinder is also capable of push and hold applications, where you can set the amount of force that you would like to exert for your application. In fact, we can even go up to 2 tons of force with the largest robo-cylinder. And since the robo-cylinder has encoder feedback, we can exert that force over whatever distance you tell us. Try that with an air cylinder. This study, performed by a leading technological university, shows that compressor technology is only 14% efficient, meaning that for every dollar you spend on electricity to run an air system, only 14 cents of that dollar equates into motion at the air cylinder level. 86 cents of that dollar is lost in inefficiencies, such as 50% loss due from heat dissipation at the compressor, 16% air cylinder loss, 15% piping pressure down loss, and 5% due to air filter and other losses. And this is assuming a no-leak environment. The average 3/8-inch air leak can cost your plant in excess of $30,000 a year. From a green standpoint, and we all want to be green these days, this 50-year-old technology is not helping out the environment. On contrast, the robo-cylinder runs on 24 volts power supply, and since the motor is directly coupled to the ball screw, we are about 90% efficient. In this demonstration, we're comparing the cost to run this air cylinder using compressor technology compared to the robo-cylinder using 24 volt technology. Both cylinders are positioning a 10 kilogram mass, and as you can see from our cost display, the air cylinder costs slightly over $25 per month in electricity, where the robo-cylinder costs just over $2 per month. If you annualize this, you can see that the air cylinder would cost slightly over $300 a year in electricity. Most manufacturing plants have hundreds, if not thousands, of air cylinders. Let's take an example of a plant with 100 air cylinders. At $300 a month, you're in excess of $30,000 a year in electricity costs. Compare that to the robo-cylinder, which would put you around $2,500 per year in electricity. That's giving you a savings of over $27,000 in electricity costs. So if you ask me which one costs more up front, well, let's take a look at the air cylinder. An air cylinder, 2 flow control valves, 2 reed switches, a positioning valve, tubing, brings the cost up to close to $400. And that doesn't even include the valve manifold, the filter regulator, or the compressor, which would easily bring the cost up into the thousands. When you look at our robo-cylinder, this robo-cylinder is about $750 for a complete system. That's no sensors to wire, no tubing to run, and by the way, the robo-cylinder is zero maintenance for the life of the actuator due to our patented AQ seal design. Okay, so let's recap. If you can buy a robo-cylinder for about the same cost as an air cylinder and have greater flexibility, greater control, longer life, better for the environment, zero maintenance, and at a lower total cost, why would you ever buy an air cylinder again? Please visit intelligentactuator.com for more information.